Welcome to Dashcoder. In this video, we are going to explore machine learning basics, explained in a simple, beginner-friendly way. Machine learning is one of the most powerful technologies shaping our world today, from recommendations on Netflix to self-driving cars and intelligent chatbots. If you have ever wondered how machines learn, how machine learning is different from traditional programming, or how you can start learning it step by step, then this video is for you. By the end of this session, you will have a clear conceptual understanding of machine learning, its workflow, its types, and its real-world applications. So, let's begin our journey into machine learning. Before we dive in, let's take a quick look at what we will cover in this video. First, we'll start with an introduction to machine learning, where we understand what machine learning actually means. Next, we'll break down the machine learning workflow, explaining how data is converted into predictions and results. Then, we'll explore the types of machine learning, including supervised, unsupervised, and reinforcement learning. After that, we'll discuss common applications and real-world examples, so you can clearly see how machine learning is used around you every day. Finally, we'll wrap up with a summary and learning path, guiding you on how to continue your machine learning journey step by step. This structured approach will help you build strong fundamentals without feeling overwhelmed. In this section, we focus on the introduction to machine learning, which is the foundation of everything that follows. Understanding this part is extremely important, because machine learning is not just about coding, it is about teaching machines to learn from data. We will start by answering a very common question. What does it actually mean when we say, a machine learns? Then, we will clearly compare traditional programming with machine learning-based programming, so you can see why machine learning is revolutionary. This section will help you build the right mindset before moving into workflows and algorithms. So let's begin with the core idea of machine learning. What does machine learning actually mean? Machine learning is a technique where computers learn from data instead of being explicitly programmed with fixed rules. In traditional programming, we define every instruction manually. But in machine learning, we provide data, and the system automatically identifies patterns and improves its performance over time. The learning process begins with collecting and processing data. This data is then used to train a model, which learns relationships and makes predictions on new data. A common real-world example is platforms like Netflix, YouTube, and Amazon. They analyze user behavior such as searches, views, and clicks, and use machine learning to recommend content you are most likely to enjoy. In simple terms, machine learning allows machines to learn from experience using data, making them smarter and more adaptive over time. Now let's clearly understand the difference between traditional modeling and machine learning. In traditional modeling, humans manually design rules and logic. We provide data and a handcrafted model to the computer, and the computer simply follows those predefined rules to produce a result. If the rules are wrong or the environment changes, the system fails unless we rewrite the logic. In machine learning, the approach is completely different. Instead of writing rules, we provide sample data along with expected results. The computer learns patterns from this data and automatically creates a model. Once the model is trained, we can give it new data, and it generates predictions without needing new rules every time. In simple terms, traditional programming tells the computer what to do, while machine learning allows the computer to learn how to do it from data. This ability to learn and adapt is what makes machine learning so powerful. Now let's understand why machine learning matters so much in today's world. First, the industry and daily life impact. Machine learning is driving innovation across industries by automating repetitive tasks, improving accuracy, and enabling smarter decision-making in everyday life. Next, data and computing power. The explosion of big data, cloud platforms, and high-performance computing has made advanced machine learning models faster, more scalable, and more reliable than ever before. Finally, relatable real-world examples. Applications like recommendation systems, voice assistants, fraud detection, navigation apps, and personalized services clearly show how machine learning has become a part of our daily routine. Together, these factors explain why machine learning is not just a future technology, it is a critical part of the present. Before moving further, let's understand some key terminologies and core concepts used in machine learning. First, algorithm. An algorithm is a set of rules or instructions that tells the machine how to learn from data and solve a specific problem. Next, model. A model is a mathematical representation created by applying an algorithm to data. Once trained, the model is used to make predictions or decisions. Now, training. Training is the process of teaching a model by feeding it data and adjusting its parameters so it learns patterns accurately. Next, feature. Features are individual measurable characteristics or properties of data, such as age, price, color, or temperature, that help the model make decisions. Finally, prediction. A prediction is the output generated by a trained model when new input data is provided. Understanding these terms is essential, because every machine learning system is built using these core concepts. Now that we understand the basics of machine learning and key terminologies, it's time to move to the next important section, Machine Learning Workflow Explained. In this section, we'll see how machine learning works step by step, from raw data to final results. You'll clearly understand how data is collected, how models are trained, and how predictions are generated in real-world systems. This workflow is the backbone of every machine learning application, so let's break it down in a simple and practical way. Every machine learning system starts with data, and the quality of that data directly decides how good the final model will be. The first step is data collection. This involves gathering raw data from different sources such as databases, sensors, APIs, or user interactions. Next comes data integration, where data from multiple sources is combined into a single, consistent dataset so that it can be used effectively. After that, we perform data cleaning. Here, we remove missing values, duplicate entries, noise, and incorrect data to improve overall data quality. Once the data is clean, data labeling is done, especially for supervised learning. This means assigning correct labels or categories so the model knows what it is learning. Then we move to data transformation, where data is converted into suitable formats using techniques like normalization, scaling, or encoding. Finally, the data is split into training, validation, and testing sets. This helps us train the model properly and evaluate its performance on unseen data. These steps together form the foundation of an effective machine learning workflow. After preparing the data, the next step in the machine learning workflow is model building and training. It begins with model selection. Here, we choose the most suitable algorithm based on the problem type and the nature of the data. For example, regression models for prediction, classification models for categorization, or clustering models for pattern discovery. Next is the training process. During training, the model learns patterns from the training data by adjusting its internal parameters. The goal is to minimize errors and improve prediction accuracy step by step. Then comes training versus validation. Training helps the model learn, while validation checks how well the model performs on unseen data. This step is crucial to detect and prevent overfitting, where a model performs well on training data but poorly in real-world scenarios. Finally, the ML model flowchart summarizes the process. Data preparation leads to model selection, followed by training, validation, tuning, and eventually deployment. This structured approach ensures that the machine learning model is accurate, reliable, and ready for real-world use. Once the model is trained, the next step is making predictions and evaluating results. In the model prediction process, the trained model applies the patterns it has learned to new, unseen data. Based on these patterns, it automatically generates predictions, such as classifying data or forecasting future values. To understand how well the model is performing, we use accuracy metrics. Common evaluation metrics include accuracy, which measures overall correctness, precision, which focuses on correct positive predictions, recall, which checks how many actual positives were identified, and the F1 score, which balances precision and recall. These metrics help us judge the reliability and effectiveness of the model. A practical example of this is spam detection. A spam filter analyzes incoming emails, applies the trained model, and predicts whether an email is spam or not. Using evaluation metrics, we continuously improve the system to ensure unwanted emails are detected accurately in real time. This evaluation step is crucial to ensure the model delivers trustworthy and real-world ready results. Machine learning does not stop after making predictions, it continuously improves through a feedback loop. In the prediction and evaluation cycle, the model regularly generates predictions and evaluates its own performance using real-world results. This helps identify where the model is performing well and where it needs improvement. The role of feedback is crucial in this process. Feedback allows the system to detect errors, understand mistakes, and adjust its parameters accordingly. Over time, this feedback helps improve accuracy, reliability, and overall performance of the model. This leads to a cyclical improvement process. The model is retrained with new data, updated feedback, and refined parameters. This cycle repeats continuously, ensuring the model evolves and adapts as data patterns change. In simple terms, machine learning systems learn not just once, but repeatedly, becoming smarter, more accurate, and more efficient with every cycle. In this section, we will explore the three main types of machine learning based on how models learn from data. First, supervised learning, where models learn using labeled data to make accurate predictions. Second, unsupervised learning, where patterns and insights are discovered from unlabeled data without predefined outputs. Third, reinforcement learning, where models learn through trial and error by interacting with an environment and receiving feedback in the form of rewards. Understanding these learning types is essential to choosing the right approach for real-world AI and machine learning applications. Now let's start with supervised learning, which is the most commonly used type of machine learning. In supervised learning, the model learns from labeled data. That means for every input, the correct output is already known. For example, if we are training a model to detect spam emails, each email is already labeled as spam or not spam. The model studies this data and learns the relationship between inputs and outputs. The main goal of supervised learning is to train a model that can accurately predict results for new, unseen data. Some common real-world examples include email spam detection, image classification, sales forecasting, and price prediction. So whenever you have historical data with correct answers available, supervised learning is the best choice. Next is unsupervised learning, where things get a little more interesting. In unsupervised learning, the data is not labeled. This means the model does not know the correct output in advance. Instead of predictions, the model focuses on discovering hidden patterns and structures within the data. For example, an e-commerce company may use unsupervised learning to group customers based on their buying behavior, even without knowing those groups beforehand. The main purpose here is exploration and insight discovery rather than prediction. Common examples include customer segmentation, clustering, and anomaly detection, such as identifying unusual transactions in financial systems. Unsupervised learning is extremely useful when labels are expensive, unavailable, or unknown. Finally, we have reinforcement learning, which works very differently from the other two. In reinforcement learning, an agent learns by interacting with an environment. There are no labeled datasets here. Instead, the agent takes actions and receives rewards or penalties based on those actions. The goal is to maximize total reward over time. Think of it like training a child or teaching a game character. Good actions are rewarded, bad ones are discouraged. A key concept here is agent-environment interaction, where continuous feedback helps the agent improve its decisions. Popular applications include game playing, robotics, self-driving cars, and real-time decision systems. Reinforcement learning is powerful, but it requires more computation and careful design. Now let's quickly compare the three main types of machine learning side by side. First is supervised learning. Here, the machine learns using clearly labeled data, meaning the correct output is already provided. It receives direct feedback and is mainly used for prediction tasks like classification and regression, for example spam detection or price prediction. Next is unsupervised learning. In this case, there are no labels. The model tries to understand the structure of data on its own by finding patterns or groupings. The evaluation is often indirect, and the goal is insight discovery, such as customer segmentation or anomaly detection. Finally, we have reinforcement learning. This is a reward-based learning approach where an agent interacts with an environment. The machine learns by receiving positive or negative reinforcement and improves its actions to maximize rewards. It is commonly used in games, robotics, and autonomous systems. So in short, supervised learning predicts, unsupervised learning discovers patterns, and reinforcement learning learns by trial and reward. Next, we'll explore common applications and real-world examples of machine learning, where we'll see how ML is already transforming industries like healthcare, finance, education, automation, and everyday digital platforms, helping machines make smarter decisions and improve our daily lives. Machine learning is not just a future concept, it's already a part of our everyday lives. First, voice assistants like Siri, Alexa, and Google Assistant use machine learning to understand our voice commands, recognize speech patterns, and respond more accurately over time. Next, recommendation engines on platforms like Netflix, YouTube, and Amazon analyze our browsing and viewing history to suggest movies, videos, and products tailored to our personal preferences. Another common example is spam filters. Machine learning helps email systems automatically detect and block spam or phishing emails, keeping our inboxes clean and secure. Finally, all of these applications improve user convenience. By learning from user behavior, machine learning makes digital experiences more personalized, faster, and more efficient, saving time and effort in daily activities. In short, machine learning quietly works behind the scenes, making our everyday digital life smarter and easier. Machine learning is transforming multiple industries by enabling smarter, faster, and more accurate solutions. In healthcare, machine learning supports early disease detection, medical imaging analysis, and personalized treatment plans, helping doctors make better diagnostic decisions. In finance, it plays a critical role in fraud detection, risk assessment, credit scoring, and algorithmic trading by identifying unusual patterns in large volumes of transactional data. In marketing, machine learning improves customer targeting, recommendation systems, and campaign optimization by analyzing user behavior and preferences in real time. Another rapidly growing area is autonomous vehicles, where machine learning helps systems understand surroundings, recognize objects, and make real-time driving decisions. Overall, machine learning significantly enhances operational efficiency and decision-making accuracy across industries. Real-world success stories show remarkable improvements, such as more accurate medical diagnostics and highly effective fraud detection systems, proving the real impact of machine learning in today's world. While machine learning offers powerful capabilities, it also comes with important limitations that must be carefully managed. One major challenge is data bias and overfitting. If training data is biased or incomplete, the model may learn incorrect patterns, leading to unfair or inaccurate predictions. Overfitting occurs when a model performs well on training data but fails to generalize to real-world data. Another key issue is real-world deployment challenges. Deploying machine learning models at scale requires handling large data volumes, adapting to changing data patterns, and maintaining model performance over time. These factors increase system complexity and operational costs. Finally, ethical considerations play a crucial role in machine learning. Issues such as privacy, fairness, transparency, and accountability must be addressed to prevent misuse and build trustworthy AI systems. Understanding these limitations is essential to develop responsible, reliable, and effective machine learning solutions. Machine learning is evolving rapidly, opening up exciting future trends and career opportunities. One key area is emerging technologies. Advanced fields such as deep learning, edge AI, and quantum machine learning are pushing the boundaries of what intelligent systems can achieve, enabling faster, smarter, and more efficient solutions. Another major trend is industry expansion. Machine learning is increasingly being adopted across healthcare, finance, manufacturing, and many other sectors to improve automation, prediction accuracy, and decision-making processes. For beginners, this growth presents a strong opportunity. Focusing on core concepts like data handling, algorithms, and model evaluation, along with building hands-on projects, is the best way to stay competitive and future-ready in the AI-driven world. The future of machine learning is not just innovative, it's full of possibilities for those who start learning today. Let's quickly summarize what we've learned and how you can move forward. Machine learning enables systems to learn from data, make predictions, and improve over time without explicit programming. We explored its workflow, key concepts, different types, real-world applications, limitations, and future trends. Now, the learning path. Start with strong fundamentals, statistics, basic mathematics, and Python programming. Next, understand core machine learning algorithms and workflows. Then, practice with real datasets by building small projects like spam detection, recommendation systems, or prediction models. Finally, move toward advanced topics such as deep learning, deployment, and real-world problem-solving. Machine learning is a journey, not a destination. With consistent learning and hands-on practice, anyone can grow in this field and build impactful solutions. This is just the beginning. Getting started with machine learning has never been easier, thanks to powerful and accessible tools. Platforms like Google Colab allow beginners to write and run Python and machine learning code directly in the browser, without any complex setup. Libraries such as scikit-learn provide simple and efficient tools for building traditional machine learning models, while TensorFlow enables the development of advanced deep learning applications. In addition to tools, there are countless online tutorials, courses, and documentation available that guide learners step by step, from basics to advanced concepts. However, the most important step is hands-on practice. Actively experimenting with datasets, building small projects, and testing different models is the key to truly understanding and mastering machine learning. Learning tools is important, but applying them is what turns knowledge into real skills. To grow successfully in machine learning, the right approach matters as much as the right tools. First, focus on hands-on projects. Practical experience helps you truly understand concepts and builds confidence. At the same time, maintain continuous learning, because machine learning is a fast-evolving field. Second, join learning communities. Participating in forums, online groups, and discussions allows you to exchange knowledge, ask questions, and stay motivated by learning with others. Finally, set realistic goals. Break your learning journey into small milestones and celebrate each achievement, whether it's completing a course, building a project, or understanding a new concept. Consistency, curiosity, and patience are the keys to long-term success in machine learning. Keep learning, keep experimenting, and enjoy the journey. Thank you for watching this complete introduction to machine learning. I hope this video helped you understand the core concepts, real-world applications, limitations, and future opportunities in a clear and practical way. Machine learning is a journey of continuous learning, experimentation, and growth. Stay curious, keep building projects, and never stop exploring new ideas. If you found this video helpful, support the channel by liking, sharing, and subscribing to Dash Coder. See you in the next video. Until then, keep learning and keep coding.